Welcome to Learning with Philemon. In this video, we will be looking at covalent bonding. In the previous video, we saw that atoms can bond together to form molecules and compounds. In this video, we will explore why atoms bond and how they do so, taking into account their electronic structure. It is more energetically favorable for atoms to have a full outer energy level. This means that that level contains the maximum number of electrons possible. To achieve this, nonmetal atoms share a pair or pairs of electrons. Nonmetal elements are found on the right-hand side of the periodic table. The simplest molecule is hydrogen. Hydrogen has an atomic number of 1 and therefore only has 1 electron in the first energy level. Only the first energy level is occupied, so the first energy level is the first and at the same time the outermost occupied energy level of hydrogen. Two hydrogen atoms are represented in the diagram, the red cross being the electron, the black circle representing the energy level, and the black dot representing the nucleus. Remember that the first energy level, sometimes represented as n is equal to 1, can contain a maximum of 2 electrons. Each hydrogen atom is missing 1 electron in order to complete its outer energy level. This can be achieved if the hydrogen atoms share their electron. In the diagram, we see that the electrons are between the two hydrogen nuclei, so each hydrogen now has 2 electrons. This diagram is called a dot and cross diagram and can be thought of as a Venn diagram, where any electrons between the two circles are shared between both atoms. Another way to demonstrate this molecule is using a Lewis structure. Here we use the element symbol H and a line between the atoms representing the covalent bond, the two shared electrons. The formula of hydrogen is H2. The subscript 2 indicates that 2 hydrogen atoms are present per molecule. Let's now look at another example. Fluorine has an atomic number of 9, so it has 9 electrons. In the electronic structure video, we saw that 2 electrons occupy the first energy level, so the remaining 7 electrons occupy the second energy level, n equals 2. Only the electrons in the outermost energy level, also called outer shell, are involved in bonding, so only the 7 electrons are shown in the diagram. The second energy level needs 8 electrons to be full, so each fluorine atom is missing 1 electron. When 2 fluorine atoms bond, they share a pair of electrons, 2 electrons. Each fluorine atom has 6 electrons that are not shared, and 2 electrons from the shared pair, a total of 8. Fluorine, F2, is a molecule as it contains 2 atoms bonded together. It is possible to share more than 1 pair of electrons. This is the case for an oxygen molecule. Oxygen has an atomic number of 8. 2 electrons are in the first energy level, and 6 electrons are in the second energy level. Oxygen requires 2 more electrons to fill the second energy level. As can be seen in the diagram, oxygen can obtain those 2 electrons by sharing with another oxygen atom. 2 pairs of electrons, 4 electrons, are shared. Each oxygen has 4 electrons that are not shared, and 4 electrons that are shared, a total of 8. In the Lewis structure, a double line is used to indicate a double bond between the oxygen atoms. 2 pairs of electrons are shared. In later IB and A-level videos, we will see that the lone pairs of electrons are also included in Lewis structures. Covalent bonds can be formed between atoms of different elements as well. Carbon has an atomic number of 6. 2 electrons are in the first energy level, and 4 electrons are in the second energy level. It is not necessary to consider the full electronic structure of the atoms. This is time-consuming, especially when looking at atoms with more electrons. You can look instead at the group number, which tells us the number of electrons in the outermost energy level. Carbon is in group 4, so it should have 4 electrons in the outer shell. Carbon is missing 4 electrons, so it must bond to 4 hydrogen atoms. In some dot and cross diagrams, the electrons of each element will be represented by a different symbol, most commonly a dot and a cross. In methane, CH4, each hydrogen has 2 electrons, one of its own and 1 from the carbon atom. Remember that hydrogen requires only 2 electrons to fill its outer shell. Carbon has 8 electrons now, 4 of its own and 4 from the hydrogen atoms. The Lewis structure is seen here. The number of electrons in the outer shell of an element determines the number of bonds it tends to form. For example, carbon tends to form 4 bonds, either 4 single bonds like in methane, or 2 double bonds like in carbon dioxide. Oxygen tends to form 2 bonds, either a double bond like in carbon dioxide and oxygen, or 2 single bonds like in water. Nitrogen tends to form 3 bonds, either 3 single bonds like in ammonia, NH3, or a triple bond like in nitrogen, N2. Noble gases, the elements in the last group of the periodic table, group 8, already have a full outer shell and do not tend to bond at all. Note that although these patterns are useful to remember, there will be exceptions you will encounter in future studies. For more practice, I would encourage you to try to draw the dot and cross diagrams of water, ammonia, and nitrogen. Remember to use the group number in the periodic table to determine the number of electrons in the outer shell. Make sure to check out the videos in the atomic structure playlist if you need to review electronic structure. If you haven't already, please subscribe for more content. Stay curious.